Hello students, secondary 1 chemistry. Now I'm still in unit 2 quantitative chemistry. Today we are going to study what is known as limiting reactant. When you react two substances together, one of the two substances reacting substances may be more than the other one. For example, when you react carbon with oxygen, these are the two reactants. If one of the two reactants is much less and the other is much more, the product may not be one compound. One of the two elements may be produced unreacted, still unreacted as it is. Why it is unreacted? Because it exists in greater amount than the other reactant. For example, carbon atoms. If we react 5 carbon atoms with 10 molecules of oxygen, each carbon atom react with 2 oxygen atoms to form carbon dioxide. But here the oxygen molecules are much greater than carbon atoms, so they are in excess. 5 oxygen molecules are in excess amounts. The carbon atoms are called the limiting reactant because they are present in less amount than the other reactant. So this substance limits the product, made the product less than the other. The other is present in excess. The problem is here that there is a shortage in carbon atoms, the number of carbon atoms. So carbon atoms here, or carbon, is called the limiting reactant, which is consumed completely, while the other reactant is present in large excess. So this is the remainder of the excess reactant. The limiting reactant is a very important substance, consumed totally, completely, and limits the quantity of the product. The reactant material consumed totally during the chemical reaction is the limiting reactant. For example, in the reaction represented in the equation, 2 magnesium atoms react with 1 molecule of oxygen to form 2 molecules of magnesium oxide. Number of moles of oxygen from the equation is half the number of moles of magnesium. So if we react 8 moles of magnesium with 5 moles of oxygen, what will happen? The 8 moles of magnesium, according to the equation, requires only 4 moles of oxygen, not 5 moles. So oxygen is present in large excess. The 8 molecules of magnesium are consumed completely, while oxygen is not used completely, is not consumed completely, but 1 mole of oxygen will remain as excess. So magnesium is the limiting reactant because it is consumed completely, while oxygen is not the limiting reactant, and but it is present in large excess, and 1 mole of oxygen of it will remain extra unreacted. Okay, this is another example, the same equation, but the quantities of reactants are present not in moles but in grams. So they are first converted into moles before determining of the limiting reactant. So converting the 64 grams of oxygen into moles, dividing the 64 grams over the mole of the mass of the mole of oxygen, which is 32, gives 2 moles of oxygen. In the same way, 12 grams of magnesium are converted into moles by dividing over the atomic mass of magnesium, which is 24. 12 over 24 gives half mole of magnesium. From the equation, 1 mole of oxygen react with 2 moles of magnesium. So 2 moles of oxygen must react with 4 moles of magnesium. React with 4 moles of magnesium. Magnesium is the limiting reactant. It is present in only half mole, not 4 moles as expected. Okay, so magnesium is the limiting reactant, and oxygen is present in large excess. Now another lesson called calculation of the percentage of elements in a compound. The percent of an element of a compound can be calculated as when you calculate your the percentage of your mark in exam. The mark that you got is put in the numerator, and the total mark is put in the denominator. In the same way, when calculating the percent of an element in a compound, percent of any element is determined using this law. Element mass in the sample, total mass of the sample, multiplied by 100. Or this is another one, molar mass of the compound in the denominator, and the mass, the atomic mass of the element, and multiplied by the number of atoms in the numerator, multiplied by 100. Let's have an example. A quarter gram of compound containing 0.18 grams of carbon. Calculate percent of carbon. To calculate the percentage of carbon, divide the mass of carbon over the mass of the compound. Divide this number over this number, and then multiply by 100, as it is here. The percentage of the other elements, 100 minus the percentage of carbon. So the answer here will be 100 minus the answer of this question. Let's have another example. Calculate the percentage of nitrogen, hydrogen, and oxygen in ammonium nitrate solution. Now, in this example, the masses of the elements and the compounds are not given, but we can also calculate the percentage of an element from the formula and from the atomic masses. To calculate the percentage of nitrogen in the compound, write this: percentage of nitrogen equal 2 atoms of nitrogen, so in the numerator 2 by 14 in the numerator. In the denominator below, calculate the molar mass of the compound as a whole. N2 by 14 plus 4 atoms of hydrogen by 1 plus 3 atoms of oxygen by 16. This is in the denominator, multiplied by 100. The product of this process is the percentage of nitrogen. To calculate the percentage of nitrogen equal in the numerator 4 hydrogen atoms by 1 in the numerator. In the denominator, the molar mass as a whole, 2 by 14 plus 4 by 1 plus 3 by 16 in the denominator multiplied by 100. To calculate the percentage of oxygen, percentage of oxygen equal in the numerator 3 by 16 in the numerator, and the denominator is the same, the molar mass multiplied by 100. That's all what I want to say. Thank you for listening, and goodbye.